Properties of logarithm. Lesson 4 examples. Solving logarithmic equations, writing the inverse, and graphing logarithmic functions. So let's look at the three different properties in here. First, the property of equality for exponential functions. We have seen this before. If b is a positive number where b is not equal to 1, then if b to the power of m is equal to b to the power of n, if and only if m is equal to n. Property of equality for log functions. If b, m, and n are positive numbers where b is not equal to 1, then log m to the base of b is equal to log n to the base of b if and only if m is equal to n. Finally, additional logarithmic properties. We have a few of them here. So if log b to the base of b is equal to, if the number and the base are same, that's equal to 1. ln e is equal to 1. Log 10 is equal to 1 because log 10 is to the base of 10. Now base means it is 10 automatically. So log 1 is always 0, whatever the base. Log 1, ln 1 is also equal to 0. So these are some additional logarithmic properties. Let's solve equations. It's pretty simple by setting the left side is equal to right side. Just eliminate. So you can see the log 4x plus 4 to the base of 6 is equal to log 64 to the base of 6. Both sides we have logarithm with the same base, so just eliminate log from both sides and you get 4x plus 4 is equal to 64, and you do the math. X is equal to 15. Over here it is a natural logarithm question. Both sides you have natural logarithm ln, you can eliminate them and you can put just 8x plus 16 is equal to x squared plus 7x plus 10 and move it around, do the math. We get x squared minus x minus 6 equal to 0. We have two factors, x minus 2 and x minus 3, the two values, x is equal to 2 or x is equal to 3. These are the two solutions for the equation right here. Number 3. Write the inverse of the given function. So this is an exponential function, and definitely the inverse of this exponential function is going to be a log function. So this is the equation. Replace y by x, x by y, and you get x is equal to negative 4 e to the power of y minus 5 minus 7. Then move this negative 7 to the other side. X plus 7 is equal to negative 4 e to the power of y minus 5, and move that negative to the other side, negative 4 actually here, and apply ln natural logarithm on both sides of this equation right here. You end up with y minus 5 equals ln of negative x plus 7 over 4, or y is equal to, the negative 5 is moved over here, ln of negative x plus 7 over 4 plus 5, or use the right notation f inverse x. Ln of negative x plus 7 over 4 plus 5 is going to be the inverse of fx equals negative 4 e to the power of x minus 5 minus 7. Example 4 is a graphing question. So we are trying to graph the function and its inverse on the same set of axes and trying to find the indicator information. We also need to find the parent points and the transform points. Also we need to determine whether the function is increasing or decreasing, and includes asymptotes. Okay, the first we need to look at the original function, which is a log function, negative log x plus 1 to the base of 3 plus 2. And we also need to find the inverse of the function, which is going to be an exponential function. This is the process of how to find the inverse of the given function. Replace y by x, x by y, and rewrite the equation back to y is equal to format. Subtract 2, x minus 2 is equal to negative log y plus 1 to the base of 3, and move the negative over here and change the log equation into an exponential equation by setting y plus 1 equal to 3 to the power of negative x plus 2. Since it is a negative, we can just flip and change the negative to a positive. 1 over, instead of putting 3 to the power of negative x minus 2, you can put 1 over 3 to the power of x minus 2. Then move that 1 to the other side, minus 1. So the inverse function is f inverse x is equal to 1 over 3 to the power of x minus 2 minus 1. Now we need to look at a couple of other things before we graph. We need to look at the parent points of the log function, which is 1/3, -1, 1, 0, 3, 1. And the transformation rule for this is x minus 1 for x and -y plus 2 for y. Also, you need to understand the a is -1, b is 1, c is -1, and d is positive 2. The points are, after you apply these two rules over here, you will get -2/3 and 3, 0, 2, and 2, 1 are going to be the 3 points for the original function. The original function right here, and plot these points, and this is going to be the red graph right here is going to be the logarithmic function right here. Now, the inverse function. To find the inverse function, we can simply switch the x and y values of these transform points over here. The -2/3 and 3 becomes 3 and -2/3, 0, 2 becomes 2, 0, 2, 1 becomes 1, 2. Plot those points plot over here, and this is an exponential graph right there. So it is very clear that the exponential function and the log functions are inverse to each other. If you can make a linear parent function here, they reflect exactly across the two, across the linear parent function. Look at the attributes. When we are actually writing the attributes of the log function, not the exponential function. Do not get confused. The domain of the log function is -1 infinity, and the -1 all the way to the right, -1 infinity. The range is all real numbers, -infinity to positive infinity. X-intercept is calculated by setting y equal to 0, which is 8, 0, and y-intercept is 0, 2. The asymptote is x is equal to -1, and the function is definitely decreasing.